We're just running through the equation of a line. So the equation of a line is basically equal to the point plus the perimeter times the directional vector. So if you have a point x1, y1, z1, you have a point x2, y2, z2, then basically you put a point in there, so it'll be like x1, y1, z1, plus the perimeter, and you could use either point. Either point will work because it's all sorted out with this perimeter, how much you put in, how much is in the point. And then the directional vector, you just do A, B. So to do A, B, you have to do head minus tail. So x2 minus x1, y2 minus y1, z2 minus z1. And that will give you the directional vector. That's the one you look at if you're looking at things that are parallel. If two lines are parallel, then they are scalar multiples. If they're perpendicular, then the dot product or the scalar product, let's call it scalar product, equals 0. All right, and where are we here? The scalar product equals 0. Okay, so we're just going to draw this vector on a plane. So it's like this. So it goes 2, 3. So if that was x, y, you go out 2, then 3 in the y, and then you have to go, now you've got to do this. So this is across, this is minus 1. So in the, oh, this isn't a 3D plane. What am I doing? Let's just make it, it's 2D. Okay, so we'll go across to 2, up to 3. Okay, and then this here, this means x, you go left 1, and then you go, and the y, you go up 2. So it's there. So that means that the line is going in that direction there. You think about that, the gradient is 2 over minus 1, or minus 2. So rise is 2, and run is 1. Okay, if you're doing it on a 3-dimensional plane, it gets a bit trickier. So let's just say this was y, x, so say that's the positive, and this was z. Okay, here goes. So we go 1, 1, 1. So crossing the positive for x, then 1 there. So we go 1 across to there to 1. And then we're going to go straight up vertically for y. I'm going to do it in a different colour. So straight up vertically. So there's the point, going up 1. All right, now the direction vector is minus 1 in the x. So it's going to be, let's do that in a totally different colour. Minus 1 in the x. You go that direction. The y, you go positive. So that's not in the x, that's that way in the x. Then you're going to go positive 1 in the y direction. And then you go up 1 in the z direction. So I went from there. So that means the vector is going to go through those 2 points.
It's 9 o'clock.
So 1 again, going that way, and then up. So go that way, and the positive in the y, then up in the x, and that will be your next point. Okay, what is the gradient of a line with the direction of vector this? This is x, this is y, so it's y on x. So it's b on a. Find the equation of the vector between 2 points. So you need, first you need your point, which is minus 7, 3, 4, plus the perimeter. Now, this will be head minus tail. 2 minus minus 7, 6 minus 3, minus 1 minus 4. So it's going to be minus 7, 3, 4, plus the perimeter. That'll be 9, 3, minus 5. Okay, determine whether the points are collinear. So you have to show that PQ equals QR. Okay? Because if you've got P to Q going in the same direction as Q to R, then they have to be on the same line. So PQ, do head minus tail, 1 minus 0. That's 1 minus 0. And then we do do 2 minus 5 and 4 minus 5. So 1 minus 0, minus 2, minus 5, 4 minus 5. We end up with 1, 3, minus 1. And then if you do QR, all they have to do is be scalar multiples. So R is 3. So you go, oops, we lost connection. Wait a minute. Let's get that back. There you go, 3 minus 1, because you're doing this one minus that one, 4 minus 2, and 2 minus 4, which is 2, 6 minus 2. If you take a 2 out of that, you get 1, 3 minus 1. And if you look at those, they are scalar multiples of each other. So therefore, the points must be in the same line, because that's saying they're parallel, but they share a common point. So therefore, they are collinear. It's because this tells you because they're scalar multiples, then they are parallel. And if they are parallel and they have a common point, then they are collinear. Okay, does a point lie on a line? Okay, so all you got to do is sub the point in. Now you got to realize that the R is X, Y, Z. That's going to be minus 5, 2, 4, plus 5, 1 minus 2, 4. So basically, if it lies on the line, the solution for X, Y, and Z, when you find phi, should all be the same. So minus 8, 8 minus 9 equals minus 5, 2, 4, plus phi, 1 minus 2, 4. So that means minus 8 equals minus 5 plus phi. Phi is minus 3. That's the X value I just did. Okay, do the Y. 8, 2, minus 2. So 8 is 2 plus minus 2 phi. Minus 2 phi equals 6. Phi is minus 3. So get the same answer again. And then do the other one. Minus 9, 4, 4. So minus 9 equals 4 plus 4 phi. Minus 9 minus 9 minus 4. So that's going to be minus 13, isn't it? Plus 4 phi equals 4 phi. So phi is minus 13 and 4. So no, it doesn't lie on the line. If you got the same phi each time, then it would. Okay, so we're just going to look at different types of equations now as well. So this is the parametric form. Okay, to find the Cartesian form, you get x is 3 minus 2 phi. Swap that around, 2 phi equals 3 minus x. So basically solve for phi, okay, and then chuck it into the other one. Because what you're trying to do is eliminate the perimeter. If you want to get the Cartesian equation, you need to get rid of that perimeter. So it's 2, 4 goes into that twice, 2, 3 minus x. Y is 2 plus 6 minus 2x. Y is 8 minus 2x. And that is in parametric form. Okay, part 2, the vector equation. So that would be x, y equals, your point would be 3, 2. So that's the first point there. Plus, factorize out lambda, minus 2, 4. And that would be your vector equation. Okay,